Behind every AI tool you have heard of, be it ChatGPT, Claude, Gemini, or Llama, there sits the same engine, Large Language Model or LLM. So what is an LLM? At the simplest level, an LLM is a probability machine. Given a sequence of words, it predicts the most likely next word. But when scaled to billions of parameters and trillions of words, this prediction engine becomes capable of reasoning like behavior. You can say it is like autocomplete, but instead of finishing your text message, it can finish a legal contract or an app's backend code. Let's say input is happy birthday to. LLM predicts the next word to be you because it has seen this phrase millions of times, so the probability of you is highest. Let's say input is once upon a time a dragon lived in a what? LLM predicts the next word to be cave. Once upon a time a dragon lived in a cave because cave statistically co-occurs with dragon more often than you can say apartment. Let's say input is a function, add numbers. LLM will return a plus b because it has learned the programming pattern of add numbers from training data. So basically, LLMs don't know the answer. They just use probabilities from past data to pick the most likely continuation. When scaled up, these predictions look like reasoning, creativity, or expertise. Let's understand how LLMs work. LLMs are trained on diverse text sources. It could be books, documentations, websites, code repos, and many other sources. The goal is not to memorize, but to learn statistical structure in a language. The model learns that certain words often appear together in sequence. Example could be the is often followed by quick. Then it learns that after quick, the next probable word is brown. So, training becomes an important part of LLM. Next comes tokenization. Words are broken down into tokens, or you can say sub-word units like play or ing. The model predicts token by token, not entire sentences. For example, playing is broken into play plus ing. ing is preceded by hash here. Hash indicates that the token is a continuation. That is, it is a suffix of a word, not the start of a new word. This is how LLMs break language into building blocks before doing predictions. Next is neural architecture or transformers. The transformer architecture powers LLMs. Key innovations here is attention layers. Attention is ability to focus on important context, and layers helps in deep reasoning across patterns. Layers or neural network processing are multiple stacked layers that transform word representations into richer embeddings. They allow the model to gradually build higher level reasoning about word meanings and relationships. Attention mechanism is the key innovation behind transformers. Instead of training every word equally, attention lets the model focus on the most relevant context. For example, when predicting the next word jumps, the model decides which earlier words matter most. Fox is more relevant than the. And then comes inference. At runtime, when you prompt an LLM, it generates responses one token at a time, guided by probabilities. Engineers can tweak temperature, that is creativity versus determinism, and top K or P sampling, that is they can control randomness. Temperature and top K or P sampling are important aspects of LLM. Let's understand these two with the help of an example. Think of temperature as the creativity dial. Low temperature, for example 0.2, signifies the model plays safe, always choosing the most likely next word. Responses are predictable but less creative. For example could be, let's say prompt is the quick fox. Output will be jumps over the lazy dog, which is very standard. On the other hand, if the temperature is set to 0.9, which is quite high, this signifies the model takes more risks, exploring less likely words. Responses are more diverse and creative, but sometimes less logical. Let's say the prompt is the quick fox. Output could be sprinted past the glowing forest. There is a creative twist here. So, temperature controls the probability of creativity for LLMs. On the other hand, sampling is controlled by top K or top P sampling. These control how many possible words the model considers before picking one. Top K, let's say if it is 50, the model only looks at the top 50 most likely words and ignores the rest. If it is top P, that is nucleus sampling, and if it is set to 0.9, here instead of a fixed number as it was in case of top K, the model considers the smallest set of words whose probabilities add up to 90% and then picks from them. Together, these prevent the model from always being repetitive or boring while keeping it from going totally random. In short, temperature is how bold or creative the choices are, and top KP is how wide the pool of choices is. So to summarize, LLMs don't understand language the way humans do. They map tokens into probability distributions, and scale makes them look intelligent. For techies, they are transformer-based sequence models. And if you're a product leader, you can consider they are the engine behind the new wave of AI products. Just to give you a brief introduction about myself, I am Ruchi. I am the co-founder and CTO of a productivity app, Habitu. Honestly, before Habitu, I had little experience in coding, but since then I have learned Flutter and I have learned Firebase. I have built many apps. Right now, my objective is to learn AI as much as possible. If you want to learn AI, stick with me and subscribe my channel.